McGraw-Hill Ascent Audio presents Leading with AI and Analytics. Build your data science IQ to drive business value. By Eric Anderson and Florian Zettelmeyer. Narrated by Timothy Andrés Pabon. Publisher's note: in this audio edition you will hear references to figures, tables, and charts present in the print and ebook formats of the book. Preface. We want to begin by sharing our inspiration for writing this book. The past 5 years have been an exciting time to be a data scientist, to say the least. More than 20 years ago, when we were both working on our PhDs at MIT, neither of us could have anticipated the incredible advances that have been made in data science and the types of data that power AI and analytics have made. That trend alone represents a sea change worth documenting and discussing in a book. But we are not just data scientists. We are also business school professors who regularly teach senior executives, consult with companies across sectors, and engage in other in-depth interactions with organizations and individuals navigating the business domain. As a result, we have had a front-row seat to the rapid evolution of data science, while also witnessing hundreds of real-life examples of applications of AI and analytics by firms and the executives who lead them. That experience has been both inspiring and sobering for us. On one hand, it's exciting to see how many new analytics techniques and tools are at business leaders' disposal. On the other, we've observed that many firms we work with have struggled to consistently add business value using AI and analytics, often investing large resources in such efforts with little return. The reason we've come to understand is that the data science is way ahead of firms' business practices. For example, every executive gets that it's important to understand a balance sheet. Nonetheless, many executives punt on knowing even the basics of data science, believing this is an area reserved for technical experts alone. Similarly, planning, a daily activity in business, is often not extended to AI and analytics. Nor is there a systematic process for finding business problems where AI and analytics could add value. The list goes on. We wrote this book to address that costly disconnect between data science and business, to close the gap in business practices needed to make AI and analytics, AIA, successful. This is not a book about data science. This is a book about what you, as a leader, need to do to make the data science work for your business and to reap the many rewards of doing that successfully. What's in the book? The book is laid out so that each section builds on your understanding of AIA in an organizational context to help you increase your data science intuition quotient, DSIQ. The sections presented are as follows. Section 1, Introduction. In Chapter 1, we explain why your role as a leader is critical for the success of AI and analytics. In Chapter 2, we present our go-to analytics framework for taking a comprehensive approach to AIA in your organization, the AIA framework. Section 2, Consuming AI and Analytics. Before you're ready to take an active role in AI and analytics, we want to give you some pointers on how to be an educated consumer of AIA. In Chapter 3, we present a systematic way to understand what is going on with your idea. In Chapter 4, we focus on how to distinguish good from bad analytics. Section 3, Actively participating in AI and analytics. This section includes 3 subsections. The first, Predictive Analytics, contains 2 chapters, chapters 5 and 6, that illuminate the inner workings of proven AIA predictive techniques, including regression and machine learning, and help you understand how to assess the quality of a predictive model and move from prediction to profit. The second subsection, Causal Analytics, Chapters 7, 8, and 9, covers how to design data using experimental and quasi-experimental approaches, and how to work with data that you have on hand or that you collect during business as usual, opportunistic data. The third subsection, Making Decisions, Chapter 10, explains how to use AIA to optimize and scale your decisions. Section 4, Executing on AI and Analytics. In this section, we turn to your role as a leader who wants to create business value. Chapter 11 helps you identify, prioritize, and plan for AIA opportunities in your business. Next, we turn to your role in transforming the organization to adapt and change so that these projects can succeed. Chapter 12 teaches you to identify barriers within your existing organization. Last, in Chapter 13, we provide our advice on how you can lead the organizational changes needed in people, data and systems, culture, and structure to support AIA. Section 5. Success Stories with AIA. We wrap up the book with real-life stories of 5 companies that have harnessed analytics effectively to create value. A word about our examples. Few things are as boring as hearing about a data science technique without an example to illustrate it. Because of that, we make extensive use of examples and stories to bring the concepts to life. We will use 3 kinds of examples. First, our real examples. You will hear some of these right off the bat in Chapter 1, including the Moneyball and Harris stories. In some cases, we can reveal the names of the company and/or individuals involved. In others, we make the real example anonymous by omitting or changing the company name, the names of actors, or the industry setting, while staying as true as possible to the real story. The North American Cable Company in Chapter 1 is one such example. Second, our narrative examples, or what we think of as historical fiction, where we combine several different businesses or characters into one and modify events to create a more streamlined and compelling narrative. These examples are inspired by real events, but ultimately represent a composite of anecdotes from multiple sources woven into a narrative set in a fictitious business context. The car ad in Chapter 1 is an example of this. The meeting and presentation really happened, and one of us was really there. But we changed the exact numbers on the figure while preserving their meaning, and paraphrased the comments of multiple participants by inventing the story's protagonist and putting the participants' comments into her voice. Third, are hypothetical examples. The ultrasound example in Chapter 1 is of this type. We constructed 3 examples fully from scratch to illustrate key concepts. Throughout the book, we will call out narrative examples and hypothetical examples. For instance, if we start an example with imagine, suppose, say, or let's assume, it indicates that you're about to hear a hypothetical example. We know you're eager to boost your DSIQ, and we are looking forward to guiding you on that journey in the chapters ahead. Let's get started. Section 1. Introduction. In this first section of the book, we'll discuss why AI and analytics are a leadership problem. They are not just a problem for leaders of AI and analytics groups or data scientists or the head of IT or the CEO. AI and analytics are your problem. In fact, they are every business leader's problem. Chapter 1 illustrates the reason for this. The most difficult decisions your organization must make to create value with AI and analytics are those in the domain of business leaders rather than of data scientists or technologists. But what makes you good at these decisions? A working knowledge of data science or a high data science intuition quotient DSIQ. In Chapter 2, we will help you increase your DSIQ by presenting our AIA framework, a go-to framework for taking a comprehensive approach to AI and analytics in your organization. Chapter 1. AI and analytics are a leadership problem. What's the best AI and analytics strategy for us? How do we start using data, analytics, and AI to drive business value like the industry leaders we read about? These are the kinds of questions C and VP level executives ask during our analytics workshops. Like most leaders across sectors, these executives are highly committed and capable, but they struggle with AI and analytics, which we will refer to as AIA throughout the book. Despite the wealth of data out there today, organizations of every type find it difficult to transform data-driven insights into profit. A recent survey of nearly 400 chief marketing officers conducted by the American Marketing Association and Fuqua School of Business showed that barely a third of available data is used to drive decision-making in businesses. Some of the barriers include a lack of processes or tools to measure success through analytics, and an insufficient presence of talent to bridge analytics to marketing practices. In fact, an estimated 85% of big data business initiatives fail. Similarly, many if not most businesses are missing out on opportunities to drive greater value with AI. This is even more alarming because AI and analytics are not just passing fads. The availability of unprecedented amounts of data and technology-enabled tools for analyzing it has fundamentally changed the way decisions are made in organizations across sectors. Data-driven decision-making is real and here to stay. We've written this book for every leader within any organization who wants to move from best guess or even misinformed decision-making to truly evidence-based decisions. Specifically, we want to provide you with a roadmap to better decisions. This book is for CEOs or executive directors who want to make the right high-stakes decisions and invest in supporting AIA organization-wide, for business unit or division leaders who want to drive results through specific AIA initiatives, and for rising leaders who want to craft strategies and tactics to create real impact. Fortunately, there is a path for any leader who wants to gain capability and confidence with AI and analytics. And the first step is to accept this book's most basic premise. AI and analytics are a leadership problem. That means AI and analytics are not just the domain of data scientists or specific departments, including those with data, analytics, or AI in their title, but also the responsibility of the highest level leaders, those in C-suite and VP level roles or their equivalent. Too many leaders still struggle with this idea, but if you agree with it, and hopefully you do, or are at least open to considering it since you're listening to this book, then the natural question becomes, how can I understand and drive AI and analytics most effectively? After all, most leaders aren't data analysis experts. You probably have solid analytical skills and capabilities that helped you advance to a leadership role in the first place, but no one's going to mistake you for a data scientist anytime soon. The good news is that to use AIA effectively in your organization, you don't need deep expertise in data science, but you do need a working knowledge of data science, a capability that can be powered by something you likely already have in abundance: critical thinking skills. This working knowledge is called a Data Science Intuition Quotient, or DSIQ. Note that we purposely use intuition rather than intelligence to emphasize that it's about having a feel for what constitutes good AI and analytics, rather than some innate ability to create and recognize effective analytical approaches. A high DSIQ enables you to do three critical things. Identify what good analytics looks like and doesn't look like. Understand where AIA can add value in your organization. Lead AIA-driven business initiatives with greater skill and competence. Boosting your DSIQ is the first step. It will help you catalyze similar growth in your organization, namely to take the specific steps and make the specific investments required to build more powerful AI and analytics muscle. Through our training and consultation sessions with business executives, we have seen firsthand how improved DSIQ can greatly benefit an organization. Moneyball, the real story. To illustrate the intimate relationship between leadership and AI and analytics, we're going to share our take on the well-known Moneyball narrative of a Major League Baseball team's analytics-driven turnaround. Moneyball, a concept popularized by Michael Lewis in his book of the same name, has become shorthand for applying statistical analytical techniques to data to develop sports strategy, especially to optimize scouting and recruiting new players or making trades. This is a major departure from the traditional reliance on scouts and managers' intuition. In his book, Lewis shares the story of the data-fueled rise of the Oakland Athletics, A's, baseball team early in the new millennium. But few people realize the real meaning of the Moneyball story. While the application of analytics has always taken center stage in this narrative and those like it, the real star and force for change is something much simpler. We'll get there momentarily, but first let's take a look at the story's original context. Billy Beane was the general manager of the Oakland A's at the turn of this past century. He'd started his professional baseball career as a player, traded among several teams, including the A's, spending stints in the minor leagues, never meeting scouts' original expectations. Things changed when he voluntarily transitioned from the A's players roster to the scouting organization in 1990. As a scout, Beane demonstrated talent for identifying high-potential players, ultimately rising in 1997 to the general manager role, a top leadership role in baseball organizations. Unlike most sports, recruiting for baseball happens not at the college level, but with focus on high school players. So most professional baseball organizations maintain extensive scouting arms, visiting high schools nationwide to recruit talent. Traditionally, players were recruited for their strengths with standard skills such as hitting, fielding, and base running. Of course, money was a major factor in recruiting success, but in the late 1990s, when Beane took the reins, the A's had very little of it. A $40 million recruiting budget compared to American League rival New York Yankees, who spent about 3 times that amount. Beane had to think differently, and did. In 1999, he recruited a new assistant named Paul DePodesta, a young Harvard economics major who'd proven himself with the Cleveland Indians. DePodesta helped Beane overhaul the team's recruiting approach. Instead of seeking out traditional skills, they targeted recruits based on other factors, specifically the statistics most likely to contribute to scoring runs, which drives baseball wins. Conventional wisdom was that metrics like batting average and runs batted in, RBIs, led to wins, and nearly every team in baseball paid attention to them. The big aha from the analytics was that on-base percentage, OBP, the proportion of times a batter reaches base, and slugging percentage, number of total bases divided by number of at-bats, were also drivers of success. Because traditional recruiting didn't pay a premium for these metrics, focusing instead on overall batting average, for example, Beane was able to create an arbitrage opportunity by affordably recruiting players who struggled with sought-after stats, but outpaced others on metrics uncovered by the analytics. As the A's roster included more and more analytically recruited players, the team's win rate rose. The A's reached the playoffs every year from 2000 to 2003, winning 20 consecutive games in 2002. In 2006, the team advanced to the American League Championship Series, just one step short of the World Series. That season, the A's were 24th of all 30 major league teams for payroll, but finished with the 5th best regular season record, highlighting the cost-effectiveness of Beane's analytical approach. Not surprisingly, other baseball teams adopted a similar approach, seeking out players with off-the-radar stats that translated into more runs. Results came quickly. For example, Theo Epstein, who had worked with DePodesta, used a Moneyball approach as general manager of the Boston Red Sox and as president of baseball operations for the Chicago Cubs, leading both teams to win the World Series in 2004 and 2016, respectively. The Red Sox hadn't done that in 86 years, and they did it again 3 years later. The Cubs in a world-famous 108 years. We can trace these headline-making successes back to the Oakland A's team Billy Beane helmed in 2002. The Moneyball story is baseball's analytics moment, a truly revolutionary development that quickly rippled out to other arenas, changing the strategies and tactics for other sports, leagues, and teams to be much more driven by data and analytics. All major sports teams today now use analytics for decision-making. At the time that this book was being written, Paul DePodesta was the chief strategy officer for the beleaguered Cleveland Browns football team, for example. But why did this specific revolutionary moment for analytics in sports arrive around 2002? Why for the A's specifically? What was the catalyst for it? The driving engine? The way most people think of this story, the most powerful pistons in that engine were data and analytics. Beane and his front office team were able to apply the latter to the former to identify and recruit valuable players' teams with much more money overlooked. That leads people to believe it was most likely some combination of new data, innovative statistical methods or computational capabilities, and more skilled talent that drove baseball's analytics moment. Let's consider each of those explanations. First, consider baseball data. Did the turn of the millennium mark a revolution in the availability of new, better data in the sport? Not by any stretch. Such numbers had been available since the late 1800s, in part because of managers' and fans' obsessions with sports data. In fact, it's safe to say the data about batting and pitching in a Yankees versus Red Sox game goes just as far back as historical weather data about the East Coast. So, if it wasn't about new data, was it the case that Bean and his ilk took advantage of new statistical methods or higher-powered computing to coax new insights out of old data? No, and no. Most of the analytical approaches in question were based on regression, a long-standing statistical approach used to predict one variable, such as runs scored, on the basis of others, OPB and slugging percentage. Similarly, the analyses didn't require particularly high-powered computing. A standard desktop computer would have sufficed. Maybe then it was about statistical talent. Did the application of an analytical approach to the A's recruiting require new statistical talent? People with revolutionary approaches to recruiting analysis? You can probably guess the answer here. Nope. Bill James, a legend in baseball statistics, coined the term sabermetrics from SABR, the Society for American Baseball Research, for the systematic application of analytics to baseball statistics as early as 1971. He had advocated for the importance of statistics like OBP long before Billy Beane became the A's GM. If none of those factors could explain the timing of baseball's analytics moment, we have a puzzle. In fact, it's the same conundrum so many organizations face today. They have volumes of data, a wide range of powerful statistical methods, including those powered by machine learning and computational capabilities, like those based in cloud computing, and ample statistical talent, data scientists. But something still prevents them from using AI and analytics for effective decision-making. That something is leadership. The best explanation for why baseball's analytics moment came specifically in 2002, and specifically for the Oakland A's, is Billy Beane himself, the general manager who'd gone from failed player to movie-worthy baseball executive by leading in a revolutionary way, one that staked the future of a floundering team on the unconventional application of analytics. Beane's appreciation for and belief in the power of analytics, combined with the need to do something drastic to improve his team, motivated him to create a management approach and structure rooted firmly in analytics. The data, techniques, and tools he used weren't new, but his leadership approach was. Moneyball is an analytics moment that changed the course of a baseball team, a league, and an industry. But what makes this moment special isn't about data, statistics, or computing power. It's about leadership. As we've suggested, all the necessary ingredients for success with analytics were in place well before 2002. The same exact story could have emerged in 1997 or even 1992. But Moneyball happened in 2002 because that's the year a leader named Billy Beane decided to step up and fundamentally change how his organization made decisions. That's the real story behind Moneyball, a narrative that demonstrates that analytics is ultimately a leadership problem and shows how a single leader with the right mindset can drive an analytics revolution in a given organization or industry. Why analytics and AI are every leader's problem. AI and analytics are not just C-suite issues, they are every leader's problem. Leaders are responsible for planning, budgeting, and accountability. Leaders create organizational culture and structure, and ultimately, leaders need to make the call on tough decisions. Leaders who want to succeed with AIA recognize that these decisions are the domain of managers, not data scientists. Here we consider several reasons why AI and analytics are every leader's problem. Analytics and AI require managerial judgment. Leaders are increasingly required to make high-stakes decisions and judgment calls based on data rather than just intuition. But making the right call can be difficult, even for seasoned senior executives. To illustrate this point, here's an example from our experience at a thought leadership retreat held by a major company providing digital services to manufacturers in the automobile industry and other sectors. To preserve confidentiality, we have disguised and modified details of this story. Each participant was asked to share thoughts about what might change the future of the digital ad industry. One senior executive was animated as he began a presentation on a recent analytics initiative. "We've finally been able to close the loop between digital ads and offline sales," he said. Finding definitive associations between digital ads and sales in the auto industry is no small feat, in part because most products in the sector are sold through independent dealers, which have little obligation to share data fully with manufacturers. By bringing some of both manufacturers and dealers on board, they were able to track when people viewed or clicked on car ads, and then use cookie information from an online post-sale survey to determine whether someone who'd been exposed to the advertising actually bought a car. As the graph in Figure 1.1 shows, without exposure to digital ads, the conversion rate, the probability of purchasing a car over a 90-day window, was less than 1%. That proportion skyrocketed to 14% if a person saw both retailer and manufacturer ads online. The executive and his team concluded not only that the ads were extremely effective, but also that retailer and manufacturer ads were complements instead of substitutes. 14% is more than the sum of 3% and 5%. Most of the executive-level audience agreed. "We need to put out a press release about this ASAP," one of the executives suggested. The sales conversion figures the executive presented in the graph appeared to be evidence that advertisements helped car sales. For several minutes, the audience debated how best to monetize the firm's newfound capability to measure digital advertising effectiveness, until one of the participants, let's call her Alice, spoke up. "Hold on," Alice said, and pointed at the leftmost column where consumers had received no ads. "Why would someone not see any product-related ads?" The answer, of course, is that these people did not search for a car on the search engine. Then, pointing to the rightmost column, Alice asked, "And why would someone see ads from both retailers and manufacturers in our industry?" Another executive replied, "I suppose because those consumers searched for a type of car and perhaps a location, which then triggered keywords that both manufacturers and dealers bid for." Alice put the pieces together. "So what we have shown is that if you are not interested in a car, you don't buy a car, and if you're very interested in buying a car, you do buy one." Slowly the team understood the implication. Because retailer and manufacturer ads were targeted to people already more likely to buy a car, the relationship between ad exposure and purchase said nothing about ad effectiveness. Consumers may have purchased because of the ads, but it is also possible that they bought simply because they were already interested in buying a car. The data in hand cannot disentangle these two effects. Most of the seasoned, high-level executives on the retreat failed to see how the data presented violated one of the most basic premises of a true experiment: random assignment to conditions. They could easily have gone down the path of launching a press release and touting their new finding, only to discover later that their interpretation of the results was deeply flawed. The executives in this example are far from alone. We see examples of flawed interpretation like this with nearly every group of managers we meet. When presented with convincing-looking data, our natural instinct is to believe it. It's human nature. What's critical to remember is that the data in the advertising example before, and in most other analytics cases, is actually truthful. In the ad example, the data does tell us what happened, but doesn't tell managers what to do next. When things go amiss, it's not the fault of the data per se, but rather an error caused when a manager or group of managers offer or believe a misinterpretation of the data in question. That's what happened at that weekend retreat. That's why working with AI and analytics requires sound managerial judgment, and that judgment must be based on a working knowledge of data science or a strong DSIQ. Data can create the illusion of insight. Imagine that you're the CFO of a major hospital, and your analytics dashboard is just lit up with key data you've been waiting for. Real
Sample complete. Ready to continue?